To the lesson quiz 4-5 explanations. I'm going to go through the 5 problems on the lesson quiz for 4-5 and try to explain them. So if you messed up something, you can understand why you made that mistake and then maybe not make that mistake on future problems. So in this lesson, we are writing the factored form and we are factoring the greatest common factor. Factoring is, as I mentioned in class, just going backwards from the distributive property. So in 4-4, we distributed a number. In 4-5, we are basically pulling it out or dividing by a number to go back to what it would have looked like before we distributed. So on this particular problem, it's asking for the factored form of this. So 24v minus 84. And we want the greatest common factor. So that means I want the biggest possible number that I could divide both of these things by evenly. So thing that I want to kind of cruise through, since both of them are even, I should be able to pull an even number out. So we've pretty much eliminated, this is not going to be right automatically, because since 4 and 4 are even digits, an even number can be brought out there. 6, both of these numbers are divisible by 6, so 6 works, but we need to confirm, is it the greatest common factor? And then go on to 12. 24 divides evenly by 12, but does 84, and you can check that. If you take 12 times 7, that is 84. So 84 is divisible by 12, and I would get a 7 if I did that, and that kind of looks good right there, right? So I am going to put a 12 out there. And basically, this 12 is what I'm going to divide these terms by. So if I take 24v and divide it by 12, I'm going to get a 2 and a v. And you can think about, if I were to distribute that 12, I'd take 12 times 2v and get 24v. Then we have a minus sign, and I'm going to take 84 and divide it by 12. And from this problem right here, we should know that that's going to be a 7. So there is the right answer right there, 12 times a 2v minus 7. So let's move on to question 2. Question 2, we have choose yes or no to tell whether 3 is the greatest common factor. So what I'm going to do is I'm going to look at each of these expressions to see if 3 is the biggest number I could divide all of them by. So if I look at it, there's no 3 in this first one at all. So there's an understood 1 there. So the biggest number I could divide all those by is a 1. So this one is a no. 3 is not the greatest common factor. Moving on to the next choice. I could divide both of those by 3. So 3 is a common factor. However, they're both even numbers. So that means I could divide by an even number as well. So 3 is not the greatest because 3 and 2, so it's at least 6. So this is a no as well, because I could divide by 6 evenly. So my greatest common factor there is at least 6. Turns out it is 6. We're just determining whether or not 3 is it or not. And then we can look at this next one. 3, both of these are divisible by 3. If we want 100% confirm, we can actually factor out a 3 and see what it would be. If I divide this by 3, I get a 9n. Then there's a plus sign. And if I divide this one by 3, I get 22p. And 3 is the greatest common factor because if I look at these two numbers, I can't divide either one of those two evenly by anything other than a 1. So this is the biggest number that we could put on the outside, so it is the greatest common factor. And then if we look at this last choice here, all of these are divisible by 3, but we can confirm that that is the biggest common factor by actually factoring a 3 out and see what we get. 36 divided by 3 is 12. Minus 9j divided by 3 is 3j, and then plus 6k divided by 3 is 2k. And if we look at that, 12 and 3 can both be divided evenly by 3, but 2 can't. So none of these can be reduced any further. So this is the greatest common factor. So that is a yes. Moving on to question 3. Question 3 is the most missed question of all of the quiz questions. And it's a little bit dicey because we have to kind of fill in some blanks here. And so I'm going to write this a little bit bigger. So we have some number on the outside of some parentheses. Then there's a g minus something. And that something has an h by it. And then plus something else enclosed. So I'm just writing it a little bit larger. And if you see, we have something on the outside of parentheses. So this expression must have been factored to get that. And they say to use a negative factor. Well, there is a negative number in front of that g right there. So that's going to have to be this number here, so that when I distribute this, if I distributed a negative 5 to a g, I would get negative 5g. So that means this has to be a negative 5. So that means you should have clicked and dragged that negative 5 over to there. And then we're going to just continue on. It says plus 15h, but if I'm dividing by a negative number, if I'm factoring a negative number out, it's going to change this plus to this minus, and then 15 divided by 5 is 3. And we can kind of confirm here, if I distributed this, I get negative 5g. And that's what I'm supposed to get. If I distribute here, it's negative 5 times negative 3, which will be a positive 15 with that h. And then we have one last number. Oh, so that, let's see, that's putting a 3. So we should drag this 3 into there. And then we have a number here. So if I factor out a negative 5, I want to take negative 5 times something so that it ends up being negative 25. And that's going to be a positive 5. So I would drag this 5 into here, and we can confirm negative 5 times a negative 3h, that's going to be plus 15h, which is what we have right there. Then I take this negative 5 and I distribute it to this positive 5, and that's going to give me a negative 25, which is what we have right here. So there we go. That one's kind of challenging just because of the format of the question. If I had asked you to just factor this, I bet most of you all would have gotten that correct. Got to be able to deal with these sort of prompts though. So let's move on to question 4. Question 4, we have an area of a rectangle problem, and that's a pretty standard thing for factoring because the area of a rectangle is the length times the width, and so if I can get it as a multiplication problem, then that's the factored form. So here we go. The area of a rectangle is 12m plus 18. That area was calculated for a rectangle as a length times a width. So if I can get a length and a width as a multiplication problem, it's going to be equivalent to 12m plus 18. In this problem, they tell me the width of the rectangle is 6. So that means one of the sides of the rectangle is a 6. So what that means is 6 times something is equal to 12m plus 18. This is my width. So that means whatever's in there is my length. So I have to calculate what that is, but if I look at that, really, that's just a 6 on the outside of some parentheses. It has been factored out. So if I take 12m and divide it by 6, I get 2m plus 18 divided by 6 is 3. So if 6 is the width, then 2m plus 3 is the length, and there is that choice right there. it asked me for an expression to represent the length. The length is the part that's still in the parentheses there if I factor the 6 out. So one last question, question number 5. We have a multiple choice question. This is possibly a little bit tricky if you're not careful looking at it. We have that Tamara says she used the greatest common factor to the factor of the expression, and we want to know if she is correct or not. So how about we just do the problem. So 21x plus 56xy. And we have to calculate the greatest common factor. Tamara got a 7, and that kind of makes sense. With a 21 and a 56, they're both divisible by 7. So I'm going to have a 7 out there, but the issue is, here's an x in this one, and there's also an x in that one. So that means x is part of the greatest common factor. If there's an x in both terms, then we can factor it out or divide both of them by an x. So she should have had a 7x, so she is not correct. No, she's not correct. And the issue is the x is part of the greatest common factor. It's not just the 7. So we could finish the problem up, but really it's what she has with the x taken out of each of these and put on the outside. So it's going to be 3 instead of a 3x, and then plus just an 8y. This is what she should have done, but she didn't do that. She only put a 7 out there. So this one's no, she was wrong. It's 14, no it isn't. 7x, there we go, that's the right one. No, she is not correct. 7x is the greatest common factor, not 7. There's a factor of 7 in each one and also a factor of an x. So that is Lesson Quiz 4-5 explained.